Here is a bunch of geometry problems. I have to look here because I've got some medical information on my computer. I don't want it exposed in videos. Okay, I don't want people to know my weaknesses because then if I try to get my revenge on the Jedi, they can foil my plans. All right, ABCD is circumcised quadrilateral with AD equals 6. Circumcised means that the circle is inside it. It touches the circle. Each side touches the circle in one point. So think about what that means. I've been trying to zoom this thing. It means that this is an external point, and that these are two tangents from the external point where those two tangents are equal. I'm just going to write this in, AF equals 3. These two are equal. Don't necessarily have to equal the same, but there's another factor, AD equals 6. If AD equals 6 and AF is 3, then Z is 3. And then that makes this 3 because this is an external point and it's tangent to the circle at 2 points. So those two set, when you have an external point, tangent to the circle at 2 points, the two tangents, those two segments are equal. So that's 3, that's 3. They also happen to be equal to 3 there too, but they don't have to be. And likewise this one, external point, it's tangent to the circle here, tangent to the circle there. CE is the same as RC, so X equals 2. And then I've got this one. Here's point B, it's 1 point. It's tangent to the circle at Q, it's tangent to the circle at R. BR equals BQ, so Y equals 4. And I think I've given all the segments, so let's see what it's asking for. It says find X. Well, X is equal, man, I can't zoom in good enough. X is equal, no, I was going to say 4. X is equal to 2. Number 10, Y is equal to 4. Z is equal to 3. Yes. And that's, remember, because of this fact, AD equals 6, and I knew that QA is 3, therefore AF is 3. Is that an F? Yeah. And if AD is 6 and AF is 3, then FD is 3. Find CD. CD is 3 plus 2, which is 5. Again, these two segments have to be equal. And then the perimeter. The perimeter is going to be 6 on the top, plus 5, plus 2 and 4 is 6, plus 4 and 3 is 7, and that comes out to, that's 12, that's 12, 12, plus 12 equals 24-ish. So the answer for number 13 is 24. X is 2, Y is 4, Z is 3, CD is 5, and the perimeter is 24. Whatever, units. They don't say inches, yards. All right, I see this question every year, and every year I forget it, and I have to work through it again. Okay, I am told that OU is 8, and I am told that XO, this is 17. Well, I also know that QV is 8, or OV is 8, and I know that this is a right triangle. It has to be a right triangle because it's a tangent point then to a radius, so it's a right triangle. All right, so this is 8, 17. You can use Pythagorean theorem to find XU, or you can know the Pythagorean triple. It's 8, 15, 17. So now I'm going to zoom in to show this part, and I'll do this part in blue. Here's a point Z. Z is tangent to the circle at 2 points, because it says in the question, I think, XU, XV, and ZY are tangents. So XU is a tangent, XV is a tangent, I didn't want to make those blue, and ZY is a tangent. It touches at 1 point. So ZU and ZW are the endpoints of the two tangent lines from Z, from the same point. That means they're the same. So ZU equals ZW. And likewise, since here's an external point Y, it goes to point V on the circle and point W on the circle. Maybe I'll do this in a different color. Purple. Is that going to show up? Those two are equal because they're two tangent lines to different points in the circle from the same point, so therefore they're equal. I guess I'll put 2 purples. Okay, so let me see what I have here. I know that this is 15. XU is 15 because of Pythagorean theorem. I know that XV has to also be 15 because X, there's one point X. It goes to two tangent points on the circle. Therefore, those segments are going to be the same. Both from one point, tangent to the circle, those two segments are going to be equal. So that's 15. All right, so let me check this out. I've got XU, let's see, equals XZ plus ZU. So I know that XZ plus ZU equals the whole thing XU. But that also, see ZU here? ZU equals ZW, so that equals ZU, well, equals XZ plus ZW, because ZW equals ZU. I'm just substituting it in for ZU. So now on the other side, I know that XV, and why am I using XU and XV? Because a question asks me to find XZ, YZ, and plus XY. And XY is on XV, and XZ is on XU. So I'm going to use those. All right, let me check this out. So XV equals XY plus YV. But remember, that's an external point to two tangents, so YW is the same as YV, so this also equals XY plus YW. And I can rewrite this as XU plus XV. I'm just going to add them together. That should be an XV equals, I know XU is 15. I know XV is 15. I used the Pythagorean triples or Pythagorean theorem to figure that one out. And it equals XY plus XZ. But check this out. ZW plus YW is just ZY or YZ. So these things are just YZ. So plus, I'm sorry, not those things. These two. ZW plus YW is YZ. So YZ. So 15 plus 15 equals XY plus XZ plus YZ or ZY, whatever you want to call it. And that's what it's asking me to find. XZ plus YZ plus XY, and that equals 30. All by using, when I draw a circle, I have one point, and I draw, it's supposed to be touching the circle. Draw it to the circle so it's tangent at 2 points. These segments are going to be equal. And that's what I use there. So it equals 30. All right, here's the next one. Find the radius. I want to go back to black here. Find the radius x. Well, Pythagorean theorem. If I take the sum of the legs and each one squared, x squared plus 14 squared equals the hypotenuse squared, x plus 10 squared, but I'm going to write it x plus 10 times x plus 10 so I can FOIL it. I'm not going to use a calculator. X squared, 14 squared, I think it's 196. 1 times 4 is 4, 1 times 1 is 1. Yeah, 196 plus 196 equals. Now FOIL, first times first, x squared. Inside 10x, outside times outside 10x, that's 20x. Last times last plus 100. The x squares cancel out. X squared minus x squared is 0. I will subtract 100 from both sides. 96 equals 20x. And what is 96 divided by 20? It's 9.6 divided by 2. Or, 96 divided by 20 equals 9.6 divided by 2. 2 times 4 is 8. 16. 2 times 8. So x equals 4.8. I don't know what the units are. Are there units given? So the radius is 4.8 units, whatever that is. Here's another one exactly the same. Well, not exactly the same, but similar concept. Different numbers, same concept. Find the radius x. Well, this time I'm going to do x squared plus 15 squared equals the hypotenuse squared, x plus 9 squared. I'll just write it as x plus 9 times x plus 9. And by the way, this one, watch out, because it's in inches. I'm just trying to see if there's no units given there, no units given there. Okay, this is in inches. This is x squared. 15 squared is 225 equals x times x, x squared. Inside times inside, out times outside. 9x plus 9x is 18x. And then 9 times 9 is 81. The x's squared disappear. 225 minus 81 is 4. And then 2 is 1, 12, 4, 144. So 144 equals 18x. I subtracted that 81 from both sides. X equals, let's see, 8 times 8 is 8 times 8 is 6. Yeah, so it's 8. X equals 8. And this time it's inches, because this one gave units. So there are the 4 problems on this part of the worksheet. Many of them have to do with, well, 2 of them have to do with Pythagorean theorem. The other 2 have to do with this idea that if you have one point outside of a circle and you draw its tangent line to 2 points on the circle, this segment and this segment are equal. That's how you get all this stuff.